For the week 4, the short film you guys want to watch is Unity Atoms demo. So Unity Atoms was created, I think, back then when there was Unity 5, and they try to showcase the features for the rendering capability, really nice global illumination, just overall try to showcase the animation and rendering. So it's a great demo. It has Atom 1, Atom 2, and Atom 3. So you can go ahead and check on this one on YouTube. SIGGRAPH 2017 Emerging Technology trailer is about innovative technology in SIGGRAPH. We also talk about it in class. So it is something that you can kind of check it out as well. VR Editor is a features inside of Unreal Game Engine. So Unreal Game Engine is a really powerful game engine, and it has a really cool feature that allow you to edit virtual reality within Unreal itself. Okay, the next thing we're going to go ahead and take a look at is today's lecture. So for today, we're going to go ahead and talk about rigid body and colliders. And we're going to use creating a basketball court as an example. We're going to create a physics material to add some bounciness to the basketball. And we're going to create rigid body for the basketball and apply the color texture to the floor and the ball itself. And then we're going to move on to talk about basic C# scripting for Unity. So we're going to talk about how to add a C# script, how to write a simple function for translate and rotation. We're going to move on to talk about the suggest textbook, which is the Unity Virtual Reality Project, Chapter 1, to finish the rest of the chapter. And then I provide a couple of Maya tutorials here for you guys to watch. One is on Maya's how to create a planar projection for texture map, and the other one is a Maya certification preparation. It's more of an in-depth Maya training in general. Okay, let's go ahead and start. So for the rigid body and colliders, I utilize the book called Unity Game Development in 24 Hours. I have the newer version with me on the print, and I also have an older version of the PDF file. So I'm just going to show you the PDF file here. And I'm looking at Hour 10 Collusion. You guys don't have the book because I can't really give you the book, but we can just kind of watch it on the screen. So Hour 10 Collusion. So what you learn in this hour is the basic of rigid bodies, how to use colliders, how to script with triggers, how to recast. We're not going to take a look at the triggers and recast yet, but we're going to go ahead and take a look at the basic of rigid body and basic collider. So in this hour, you'll learn to work with the most prevalent physics concept in video games, collusion. Collusion, simply put, is knowing when the border of one object has come into contact with another object. This is so-called as collusion detection. You begin by learning what rigid bodies are and what they can do for you. After that, you experiment with Unity's powerful built-in physics engine, namely Box 2D and Physics X. From there, you learn the more subtle use of collusion with triggers. You end the hour by learning to use a recast to detect collusion. So we're not doing that. But let's go ahead and take a look at the definition of rigid bodies. For objects to take advantage of Unity's built-in physics engine, they must include a component called rigid body. Adding a rigid body components make an object behave like a real-world solid entity. To add a rigid body component, simply select the object that you want and click Component Physics Rigid Body. So you make sure you choose the version without 2D on the end, so you need to be a 3D rigid body. You will notice the new rigid body component added to the object in the inspector. So it will look something like this after you add a rigid body. The rigid body component has several new properties that you have not seen yet. Okay, so here describe the properties attribute. So you can create a mesh, the mesh of the object in arbitrary units. Okay, so use 1 unit for 1 kilogram unless you have a good reason to deviate. There's drag, so that is a physical quality such as how much air resistance is applied to the object when moving. There's use gravity, so determine whether unity's gravity calculation are applied to this object. Okay, and then there's a collision detection. Determine how collision is calculated. Discrete is the default and is how all objects test against each other. Okay, and here it has a small example how to create a rigid body exercise, so we're gonna skip that. Collision. Now that you have your object moving around, it is time to start getting them to crash into each other. For objects to detect collision, they need a component called a collider. A collider is a parameter that is protected around your object that can detect when other objects enter it. Colliders. Geometric objects like spheres, capsules, and cubes already have collider components on them when created. You can add a collider to an object without one by clicking Component Physics and then choosing the collider shape you want from the menu. Okay, so what it's trying to say is that by default, when you create a geometric object, the primitive object from Unity, it already comes with basic collider. But if you use external geometry, say the geometry you created from Maya or download the asset, they might not have colliders. So you need to add your own collider by going to the Component Physics, add components, physics, box collider, and all these type of collider you can choose. Later on, once a collider is added to an object, the collider object appears in the inspector, and then this is the collider property. You can use the edit collider button to interactively adjust the collider size. If it's triggered, if it's turned on, then you determine whether the collider is a physical collider or a trigger collider. The triggers are covered in, okay, so, and then there is the size of the collider, okay? So here is talking about you can mix and match the collider. All right, so let's go ahead and take a look at the next one, which is physics material. Physics material can be applied to colliders to give objects varied physics properties. For instance, you can use a rubber material to make an object bouncy or an ice material to make it slippery. You can even make your own to emulate a specific material of your choosing. There are some pre-made physics material in the character's standard asset pack. To import them, you can choose to import that and then click on none to deselect them all. Okay, so here just kind of show you can just go ahead and import the standard assets, and there's a section for physical material that you can start using right away. So here are some of the property for physics material. So you can choose to work with the dynamic friction, bounciness, so the amount of energy retained from the collision. Value of 1 causes the object to bounce without any loss of energy. It will bounce forever. Value of 0 prevent the object from bouncing. So if you want, say like a basketball to bounce a little bit, then maybe you can put in a value between 0 to 1. All right, let's go ahead and move on to Unity. All right, we're gonna go ahead and create a basketball court with physics, material, rigid body, and color texture. So let's go ahead and bring out Unity. But before we do so, make sure you download basketball.jpg and plain.png files. Okay, so inside of Unity, after you create kind of a general project, and then this is just an exercise. Okay, so we can go ahead and go to the desktop. After you save those textures, drag those textures onto your assets folder. Okay, So let's go ahead and create a game object, 3D object, cube, and we're gonna make that as our chord. Okay, so we're gonna go ahead and scale on X. Maybe we'll make it 10. And Y will make it not so thick, so maybe 0.1. And Z, we can make it maybe 5. If you want to make it even bigger, it's up to you. Okay, so maybe we can make it even wider. All right, let's talk about how to add a texture inside of Unity. So to do so, we'll need to add a material. To add a material, hold on to the right mouse button, go to Create, Material. So with this new material, we can go ahead and choose the albedo, and then we can go ahead and choose the plane. Okay, so with this new material, we can then drag and drop. I think I have it in a round direction, so I might need to scale it on this way. There we go. And then for the basketball, let's go ahead and create a 3D object cube. I'm sorry. Game object, 3D object, sphere. Okay. If you want to make it bigger, you can. You can move it above the ground. That's what we want to do. You can adjust the size if you want to. You can make it smaller or bigger. So we can go ahead and create another material. Right mouse click, create material. And you probably should label this material, but due to the time, we're just gonna go ahead and start going to albedo, choose basketball. Now there's another way of doing this, is just drag and drop. So if I have this material created, drag the basketball's albedo right on top of the texture, and that's another way of doing a texture map. So go ahead and drag and drop the material right onto the geometry. If you go ahead and take a look at your main camera, you can see this is what the main camera look like. If you want to get a close-up view, or say maybe you wanted the camera to look at this view, we can then go to select the main camera, go to game object, align with view. And now you can see we are looking at this view from the game camera. Now we're ready to add some rigid body to the geometry. Now go ahead and take a look at the geometry. From what we read earlier, you can see that this game object that comes with Unity has a collider already built in, and by default it is enabled. So that means that this object is collision, means that object cannot penetrate to it. So what we can do right now is we're gonna go ahead and create a rigid body component for this basketball. So I'll go ahead and move it up slightly. If I go ahead and press play, you can see there's nothing happening because the balls, it just stay up in the sky. There's no physics, there's no animation, there's no movement. So what we can do then is we can choose to add a component, physics, and we can choose to do a rigid body. So with the rigid body enabled, you can see by default the gravity is turned on. You have a mass of 1, and there's just some of the basic attribute that belongs to it. So if I go ahead and play, you can see that now the basketball is moving on the y-axis because the gravity is pulling it down. However, this basketball just sit on the court and not moving at all because there's no other force for this object to move. So what we want to do then is we want to create a physics material so that will allow these balls to bounce. To do so, let's go ahead, choose right mouse button, go to create, physics material. So with this physics material, you can see you have bounciness as 0. We from the book we read earlier, bounciness of 1 is gonna give you, it's gonna be bouncing forever. So in here, we're gonna change that maybe to 0.5 just to get a basic idea. We can always change that. So after you create this new physics material, you can select the ball and then take a look at the geometry itself. It has transform attribute. It also have the sphere collider, and then there is a physics material section right here if you want to assign to it. So let's go ahead and drag the new physics material, drag and drop into this section. So now if we go ahead and play, okay, so obviously the bounciness is too low, so it does have a little slight bounce back, but it's not strong enough. So let's go ahead and choose this physics material. Let's change the bounciness maybe to 0.8 just to see how it feels like, and go ahead and play. Okay, so if you want to even be more bouncier, you may consider change that to 0.9. Can I do 0.95 maybe? Let's give it a try. Okay, so I believe maybe if we make it go taller, that will also help too. All right, so that is the basic of creating geometry, importing the texture into Unity, assign a texture, create a rigid body, assign a physics material to the geometry's collider. Let's move on to the next section. Okay, the next thing we're going to go ahead and talk about is Intro to C# script in Unity. So C# script is one of the common scripting language that is used in the Unity software. Unity also, you can also do JavaScript in here as well. Now, say in here, there is this kind of an orange color basketball is controlled by the rigid body. We're going to go ahead and create another basketball, and this time we're going to control by script. So let's go ahead and create another game object. So game object 3D object sphere. Okay, so maybe this one I'll have it sitting on the ground. I'll create a new material. Let's change the color for this material to be somewhat of a blue color. Then I will reuse this texture right on top of the albedo. Let me change it one more time. I don't think I take the color. You also need to drag in the blue box as well. There we go. Okay, so now you can see this is more of a kind of a blue basketball. All right, so now I can assign this material right on top of this blue basketball. So I want to use the coding to control the behavior of this basketball. So maybe I want it to move from the screen, from the beginning of the screen all the way there, and then start translating or moving towards this side of the screen. So what we can do is, a couple we can do it. You can choose to create a script right here, like a C# script. And then after you finish the script, you can then drag and drop on top of the object. Another way you can do is select the geometry, go right to the Add Component section in the inspector, and choose, drag it down, choose New Script. And we can call this one, say, Move capital Z. So this is going to be a move Z script, create and add. Okay, and you can see that on the project window, there's this C#. Unity 2018 start utilize Visual Studio for the scripting. Okay, so we're gonna go ahead and, well, I take that back. Visual Studio is always the option for develop for Unity. However, the default editor was Mono developed for many years for Unity. But ever since my Unity 2018, Unity decided to drop the support for Mono develop and just go with Visual Studio. Okay, so that's something, that's what I meant by utilize Visual Studio for the editor. So you can take a look at in this programming functions right here. It utilizes the Unity engines, and then you have this class. So the MoveZ is the class name. So it has two default functions. Void start, it will be called once for initialization. And then you have void update. This is called once per frame. So we want this object to translate. Every frame we want it to move 1 unit on the z-axis. So what we can do is come here and type in this. So this, you can double click on that, so you will finish the rest of the work for you. So when you refer to this, it usually when you use list, this is referred to the object that you are selecting right now. Okay, sometimes you can choose to not to type list, and if you don't type list, it will be fine, but it just meant as the attribute for this geometry. So I can type in list dot transform. Okay, so Visual Studio is pretty nice. It kind of provides me with those options already, so I can double click on that transform dot. I want this to translate, so you need to type in translate. So double click on a translate, and then I will go ahead and use the parentheses, semicolon. So in here, I need to give it the coordinate information. So every frame, I will have it on the X direction, Y direction, and Z direction. All right, so let's go ahead and give that a try, see how this will work. So go ahead and go to File, Save. Then it will compile, and what you need to do is just go ahead and play. And you can see that that ball is moving towards the screen, across the screen. With every frame, the geometry is just gonna move 1 unit further on Z direction. If you go ahead and bring out the blackboard, you can take a look at, I have a link provided for you. It's called Intro to C# Script in Unity. So the easiest way might be just go, if you're confused with certain function, you can just Google, say transform.translate in Unity, and that usually will take you right into Unity's documentation. So you can see there's public void translate, vector3 translation. So this is just kind of a basic description. Move the transform in the direction and distance of translation. Okay, so it will be transform.translate. Keep in mind there's a capital on the T, and then there's the vector3. Time.delta time is more of a fixed unit time. It might give you more accurate result compared to just using the regular. If you don't use delta time, is just for computer science students probably know that this is going to be more of a fixed accurate timing. Okay, you can also choose to use rotation. Okay, so instead of using translate, we can also choose to use rotate. So if I want to see how to use this, I can say go ahead and go to Google and I'll search for transform.ro. I probably should search for Unity. Oh, right here, Unity Scripting API. Okay, so transform.rotate. Apply a rotation degree around the z-axis. Euler, I have hard time saying the words, the degree on that. So we can type in transform.rotate and we can do, I think instead of do vector 3, right, I would just do like 0, 10 degree and 0. Okay, so let's give that a try. So I will double click. Oh, here's my Visual Studio. Okay, so instead of doing translate, I can comment this out. So that means I'm not using it. So I'll go ahead and this time I won't use list. So I'll go ahead and type in transform. Okay. Dot capital R rotate. Okay, I just tap on the space bar too and it will finish for me. And I can semicolon here. I can do 0, 10 on y-axis every frame and 0. Go ahead and save. Okay, so I will minimize this and I'll bring these blue balls a bit closer to me. Okay, so if I go ahead and press play, you can see that now the ball is just rotating along the y-axis and every frame is rotating for about 10 degrees. This is the basic of Unity scripting. So for week 5, you guys are following a tutorial, doing it step by step. So hopefully you feel a little bit more comfortable when you start writing your own scripting. Okay? All right, let's move on. So the next thing we're going to go ahead and take a look at is the Unity Virtual Reality Project Chapter 1. That's a suggest textbook I have on the syllabus. So let's go ahead and take a look at the handout. Go ahead and make it bigger. So we go through those kind of a history, and we know that they are desktop VR. So there's Oculus Rift and HTC Vive. And the Oculus Rift is tethered to a desktop computer through a video and USB cable, and the more graphic processing unit GPU power, the better. Okay, so it's very it kind of adds a lot for the graphic card. All right, and then there's a different kind of virtual reality market, which is mobile VR. Mobile VR is exemplified by Google Cardboard. It's a simple housing device for 2 lenses and a slot for your mobile phone. The phone's display is used to show the twin stereoscopic views. It has rotational head tracking, but it has no positional tracking. Cardboard also provides a user with the ability to click or tap its on side to make selection in-game. The complexity of the imagery is limited because it uses your phone's processor for rendering the views on a phone display screen. Other mobile VR headsets, including Samsung Gear VR and the Z's VR1. That one I don't really hear of. And this book was created 2 years ago, so it might have more different devices come out. So Google provides the open source specification. So I'm sure the other developer not just Google Cardboard, but they had, similar cheaper set that you can see or you can buy that is made out of plastic. We're gonna take a look at the augmented reality before, okay, and there is also different things such as Microsoft HoloLens, and we're gonna take a look at that when we come back in class. But HoloLens is an interesting device. It's more for mixed reality, okay, so because there's mixed reality, there's augmented reality, and there's also virtual reality. So Unity kind of call all these things as mixed reality, short for XR. And then there's application versus game. The consumer level virtual reality start with gaming. Video games are already accustomed to being engaged in highly interactive, hyper-realistic 3D environment. Okay, so gamers are early adopters of high-end graphic technology. Mass production of gaming consoles and PC-based components in the tens of millions, and competition between vendors lead to lower prices and higher performance. So here we move on to talk about some of the demo that you can find. Oculus Share, I don't think they call it Oculus Share anymore. Before it was called Oculus Home, but now it's just the Oculus page. And then there's also Google Play. Okay, so game developers know that the core of a game is the game mechanics or the rules, which are largely independent of the skin or the thematic topic of the game. Gameplay mechanics can include puzzles, chance, strategy, timing, or muscle memory, twitch. VR games can have the same mechanic elements, but might need to be adjusted for the virtual environment. For example, a first-person character walking in a console video game is probably going about 1 times faster than their actual plays in real life. Okay, so here kind of continue to talk about the slight difference between VR and game development. So here are some examples of the kinds of non-gaming application that people are working on. So traveling and tourism. Visit faraway places without leaving your home. Visit art museum in Paris, New York, and Tokyo in one afternoon. Or take a walk on Mars. Okay, so you can enjoy Holi, the spring festival of colors in India, while sitting in your wintry cabin in Vermont. Other applications including mechanical engineering and industrial design. So computer-aided design software such as AutoCAD and SolidWorks pioneer three-dimensional modeling, simulation, and visualization. With VR, engineers and designers can directly experience the hands-on end product before it's actually built and play with what-if scenario at very low cost. So this is great for prototyping. Or consider iterating a new automotive design. How does it work? How does it perform? So I remember back in the 90s, GM has a virtual reality setup where they can test different design for the interior. Architecture and civil engineering. Architects and engineers have always constructed scale models of their designs, if only to pitch the idea to clients and investors, or more importantly, to validate the many assumptions about the design. So presently, the modeling and rendering software is commonly used to build virtual model from the architecture plane. With virtual reality, the conversation with stakeholders can be so much more confident. Other personnel, such the interior designer, HVAC, and electrical engineer, and can be brought into the process sooner. And I showed you guys last week with Metaport camera, which can capture real estate house rendering in an OBJ format, so the realtor can showcase the client without have to fly. The client doesn't need to fly state to state. Oh, here's a real estate. So real estate agent has been quick adopter of the internet and visualization technology to attract buyers and close sales. Real estate search website were some of the first successful use of the web online panoramic video walkthroughs of the for sale property are commonly placed today. Okay, so you talk about with VR, I can be in New York and find a place to live in LA. Okay, and then there's also become more easier with the mobile 3D sensing technology such as Google Project Tango, which perform a 3D scan of a room using a smartphone and automatically builds a model of the space. Though that will be similar to the technology we were looking at last week, photogrammetry. Medicine. The potential of VR for health and medicine may literally be a matter of life and death. Every day, hospitals use MRI and other scanning devices to produce models of our bones and organs that are used for medical diagnosis and possibly pre-operative planning. Using VR to enhance visualization and measurement will provide a more intuitive analysis. Virtual reality is also being used for the simulation of surgery to train medical students. Mental health. Virtual reality experience has been shown to be effective in a therapeutic context for the treatment of post-traumatic stress disorder in what is called exposure therapy, where the patient, guided by a trained therapist, confronts their traumatic memory through the retelling of the experience. Similarly, VR is being used to treat, don't know how to say this, but spiders and the fear of flying. Education. So the educational opportunity for VR are almost too obvious to mention. One of their first successful VR experience is a Titan of Space, which lets you explore the solar system firsthand. Science, history, arts, and mathematics. VR will help students of all age because, as they say, field trips are much more effective than textbook. Training. Toyota has demonstrated a VR simulation of driver's education to teach teenagers about the risk of distracted driving. So this, training, of course, you can use in many different way of training. Even military, government used training to teach employee. Company can also do that as well. Entertainment and journalism. Virtually attended rock concert and sporting events. Watch music video, erotica, re-experience news event as if you were personally present. Enjoy 360-degree cinematic experience. The art of storytelling will be transformed by VR. Okay. So that's pretty much the chapter 1. Okay, so they continue to talk about the type of VR experience. Then there's not just one kind of virtual reality experience. In fact, there are many. Consider the following type of VR experience: diorama. In the simplest case, we build a 3D scene. You are observing from a third-person perspective. Your eye is the camera. Actually, each eye is a separate camera that gives you a stereoscopic view. Then there's the first-person experience. This time, you're immersed in the scene as a freely moving avatar. Using an input controller, such as your keyboard and controller or some other technique, you can walk around and explore the virtual scene. Interactive virtual environment. This is like the first-person experience, but it has an additional feature. While you're in the scene, you can interact with the object in it. Physics is at play. Object may respond to you. You may be given specific goal to achieve and challenges with the game mechanics. You might even earn points and keep score. Riding on rails. In this kind of experience, you are seated and being transported through the environment. For example, you can ride a roller coaster through the virtual reality experience. However, it may not necessarily be an extreme thrill ride. It can be a simple real estate walkthrough or even a slow, easy, and meditated experience. And 360-degree media. So think panoramic images taken with GoPro on steroids that are projected on the inside of a sphere. You are positioned at the center of the sphere and can look all around. Okay, some purists don't consider this real virtual reality because you are seeing a projection. So that's more of a 360. To me, that's not really a VR, but it is kind of a nice surrounding view. Social VR, when multiple players enter the same VR space and can see and speak with each other's avatar, it becomes a remarkable social experience. And following is the technical skills that are important to VR, understanding the world scale, understanding what is the first person control, how to utilize the interface, how to create the canvas, physics and gravity. So say using a rigid body or physics material and a gravity to control the object. You can also use coding as well. Animation, moving object within the scene is called animation. It can either be a long predefined path, or you may use AI, depending on which one you choose. If we animate keyframe inside of Maya, then that is more of a traditional animation. There's also AI implemented inside of Unity, such as Nav Mesh, that can control the avatar or characters moving. There's also multi-user service, so you can also create a networking game or networking VR experience, build and run different hand-mounted display, use different developer SDK kit. So you can choose to use Unity. In this case, the book used Unity to create different executable. All right, so that kind of summarized for this chapter 1. And the following, this one is a tutorial that I recorded in Vimeo. So you can type in a password, you can watch the tutorial on how to create a planar texture map for Maya. And then here is more Maya resource to review or actually an overview on some of the Maya feature. So I think that kind of conclude for this week's lecture. So please utilize your time and following those tutorial, and you can pause, you can watch it again, you can step through. So hopefully you find something useful for you for this week. And then next week's lecture will be ready by the end of this Sunday. By the end of this week. Now, let me remind you that the week 5 is more on creating a research paper. In terms of preparing for it, and then complete your midterm project template. So the lecture section will be kind of small. So I will show you how to use the OVR utility to grab an object. But there's also another tutorial that you need to do is follow this step-by-step tutorial to create your first VR app. Okay, so I will see you online in another week.